Okay, guys. So this is the lecture from section 12.2. So 12.2, you guys have a PowerPoint. Some problems are being solved for you. Some of them I'm going to solve it and review with you guys during this lecture. So 12.2, it's also about solving system of equations. But in this section, we're going to focus on solving system of equations using substitution method. So we're still going to have two equations which will represent the graphs of straight lines, and we will try to find the point of intersection, if it's possible, if they're intersecting, without graphing. In this case, we're going to use algebra. And the method which we're going to use is substitution. So first I want to talk about the example which shows you all the steps of how to use substitution method when we're solving system of equations algebraically. So here on the left side, you have system of equation. The first equation is x equal 2y minus 3. This is the equation of a straight line. It's all over the place, but yes, it's definitely straight line. You have x and y variable, bring it to the first power. And the second equation is negative 4x plus 3y equal 2. So what we're trying to do, we're trying to figure out without graphing at which point those two straight lines will intersect. So we're going to use the substitution method. What that means, look what happened. The first equation, it's been solved for x. So this is perfect. What we're going to do, because don't forget that when you're solving system of equation, you find the point of intersection. So that point, which has x coordinate and y coordinate, belongs to two straight lines, which means here when we have x equal 2y minus 3, eventually later will represent the point of intersection, you're going to substitute the x from the second equation with the expression 2y minus 3. So this is what we're doing here. The first equation, it's been solved for x. We know that x is the same as 2y minus 3. And what we're going to do with that, we're going to replace x from the second equation with the expression 2y minus 3. So like you guys see right here, we work on the second equation, which is negative 4 times x plus 3y equal 2. And this x, we're replacing with 2y minus 3, okay, which means with the x from equation 1. And you're just going to continue. And why we're using the substitution? Because look what happened. The second equation right now only has one variable, which is y. So we're going to distribute negative 4 to both sides. So we end up with negative 4 times 2y, which is negative 8y, negative 4 times negative 3, positive 12, plus 3y equal 2. We're solving this equation for y, and we end up with y equal 2. When you have y equal 2, which represents the y coordinate of the point of intersection, now we're going back to the first equation right here, which is x equal 2y minus 3. And where you had y, you're going to plug it in too. So to find x, we're going to substitute y equal to back in the first equation. And that will give you x equal 1. So what that means, you have x equal 1, y equal 2. X and y, when you solve the system of equations, represents coordinates of the point where two straight lines intersect. So those two lines intersect. So the solution here, it's a point of intersection, x comma y. So we know that those two straight lines intersect at point 1 comma 2. Okay, so this is what we're going to do in this lecture. We're going to use the substitution method. Okay, substitution method. Sometimes they will give you nice equations where it's very easy to do the substitution. Sometimes we need to use our algebra skills. To rearrange the equation a little bit to be able to use the substitution. Okay. So next, what we're going to do, we're going to practice how to solve system of equations using substitution method. So let me go over this problem. On your PowerPoint, it's not been solved, so I'm going to solve it with you guys. So again, this is system of equation. I like to label my equations. So this is equation 1, this is equation 2. Okay. So what we're going to do, in this case, equation 2, it's been solved already for y. We know that y is equal to x plus 1. So what we're going to do, we're going to replace y from the first equation with y from the second equation. And y from the second equation is equal to x plus 1. Okay? So let me just write this down. So substitute y from equation 1 with x plus 1. Okay, so we're working with equation 1. Okay, so let me just put it that way, equation 1. So equation 1 is 2x plus 3y equal negative 2, and we're replacing y with x plus 1. Equal negative 2. So again, the same equation, we're replacing y with x plus 1, because now we have nice equation which only has one variable. So when we have that, we're going to solve it for x. So we have 2x plus 3x plus 3 equal negative 2. Combine like terms. That will give you 5x plus 3 equal negative 2. Subtract 3 from both sides, and we're having 5x equal negative 5. We're going to divide both sides by 5, and we end up with x equal negative 1. So we know that this system will have a solution, which is one point of intersection E, and we already know the x coordinate. So now when you have the x coordinate equal negative 1, so again, that was the first step. The second step will be substitute x from equation 2. Since we're done with equation 1, now we're moving to equation 2 with negative 1 in order to get y. So what we're going to do, we're going to replace x from the second equation with negative 1. So the second equation, equation 2, is y equal x plus 1. We're going to replace that x with negative 1. So that will be negative 1 plus 1. So we're having that y is equal to 0. What that means, that the solution is the point which has coordinates negative 1, comma 0. So again, those two straight lines, because those equations represent straight lines, intersect at point negative 1, comma 0. So we have one solution. And that point represents the point of intersection. So everything what we're doing and what I'm explaining verbally, you guys have all the steps written for you on the PowerPoint, how to solve system of equation using substitution method. So step 1, isolate one of the variable from one equation. In the two equations which I went over, that was being given for us. either we had one equation was isolate x, the other equation isolate y, so we didn't have to follow step one. But the next problems, like you guys see here, we'll need to do it. So step one, isolate one of the variable from one equation. Step two, substitute the expression find in step one into the other equation. Step three, solve the resulting equation. So that's when your equation has only one variable. 4. Substitute the value find in step 3 back into equation in step 1 to find the value of the remaining variable. Check the order pair in both original equations. So again, it looks, you have all the steps. When I'm solving those problems with you guys, of course, I'm going to tell you exactly what I'm doing. So that will become more friendly for you. So let's talk about the second equation, second system. We have to find the point of intersection where those two straight lines intersect. So when you guys solving system of equations, I recommended to label them. So equation 1, and we have equation 2. Okay. So what happened? I'm trying to use the substitution, but look, in this case, none of the equation it's been solved for any of the variable. So what I'm going to do, I'm going to pick the equation which looks easy. So I'm going to pick the first equation because definitely this first equation looks easier than the second equation. And so again, I'm going to start with equation 1 and isolate. You have two choices. You have to solve this equation for x or y. I'm going to solve for x. So, and isolate x. So let me copy that equation 1 is x plus y equal 4. Solve this equation for x. So we're going to subtract y from both sides. That will give us that x is equal 4 minus y. Now when you solve the first equation for x, you're moving on to the second step, where they're telling you to substitute the expression find in step 1 into other equation. What that means? Now when I know what is x equal, I'm going, next. So when you solve the first equation for x, work with equation 2. So work with second equation and replace x from the second equation with the expression of x from the first equation, which is 4 minus y, with 4 minus y. Okay, so what we're going to do, we're going to take that x, which is equal 4 minus y, and we're going to plug it in right here. So we're going to work with the second equation and replace x with 4 minus y. So let me show work. So I'm showing work. So we're going to start with equation 2 right now. So it's -5. We're going to replace this x with 4 minus y. That's the x from the first equation. And the rest you just copy the way it is. So this is -5 times 4 minus y plus 3y equal -12. And the rest, what you're going to do, just solve equation for y. Distribute first. So we have -20 plus 5y plus 3y equal -12. Solve for y, so combine like terms. Here we're getting 8y. -20 plus 8y equal -12. Add 20 to both sides. And we're getting 8y. It's equal 8. Divide each by 8. And we know that y is equal 1. So when we got y equal 1, okay, Now, when you have that, go back to equation 1, which is x equal 4 minus y, and substitute y with 1. So that will give you, let me put that, x equal 4 minus, and again, we know that y is equal 1, so 4 minus 1, and that will give us 3. So now we know y is equal 1, x is equal 3, which means the solution is a point, and again, I'm trying to squeeze it here, so the answer for this problem will be 0.3, 1. So again, that's the answer for the, okay, maybe put it here. So answer, it's the point of intersection, it's 3, 1. Okay, so this is how you're using the substitution method. So the idea is to start with picking the equation which looks easy, solve this equation for one of the variable, like I did right here, and then start working with the second equation, substitute, in our case, x with 4 minus y, solve the second equation for y, and again, you have to go back to what you did in the first step, which is substitute back again. It looks like a many step, but I think you guys can use them. So this is one way of solving systems of linear equations. So in this lecture, I'm just practicing with you guys substitution method. So there's a couple of problems which I will go over. There's some half fraction. In the next lecture, I'm going to show you the other method how you can solve system of equations. So again, here I focus only on substitution. So the next one, we're going to practice. You have x plus 4y equal 11, 2x minus 5y equal negative 4. So first, what we're going to do, let me label those equations. We have equation 1, equation 2. Since equation 1 it's easier, so I'm going to start. So first, take equation 1 because it's just easier, which is x plus 4y equal 11. And you need to solve this equation for x or y. Since it's easier to solve for x, I'm going to solve this equation for x. So we will subtract 4y from both sides. And that will give you x equal 11 minus 4y. So this is the expression for x from equation 1. And what I'm going to do, I'm going to replace x from the second equation, because I didn't touch yet the second equation, with 11 minus 4y. So we're replacing x right here with 11 minus 4y. So that will be our second step. So second, work with equation 2. Replace x with 11 minus 4y. Okay, so we have our second equation. It's 2x minus 5y equal negative 4. So we have replace x with 11 minus 4y minus 5y equal negative 4 distribute that 2 to both. So that will give you 22 minus 8y minus 5y equal negative 4. Combine like terms. So you're getting 22 minus 13y equal negative 4. And solve for y. We're subtracting 22 from both sides. And that will give you negative 13y. It's equal negative 26. Divide both sides by negative 13. And we'll be getting that y is equal, that was 26 here, y is equal to. So we know y is equal to, and when we know what is y, look what happened. Now we're going back to our result from equation 1, and we're replacing y with 2. So third, go back to step 1. Where we have that equation for x. We know that x is equal 11 minus 4y, and to replace y with 2. Okay, so x will be equal 11 minus 4 times 2, and that will give us 11 minus 8, which is 3. So answer, the point of intersection, the solution of the system is point x comma y. We're having 3 comma 2. Okay, so that was another example of solving system of equation using substitution. Now I'm going to show you how the substitution method works with inconsistent system. So let's just review that inconsistent system. It's the one which have no solution. So I want to show you how to do it, okay? So how you're going to know that your system of equation has no solution. So again, inconsistent system, just going back, means no solution. So the same thing what I did before. I'm going to label both equations. So the first one is equation 1. The second one is equation 2. So since equation 1, it's been solved for y, we already know that y is equal negative 1 half x plus 3. So what I'm going to do, I'm going to skip step 1, and I'm going to replace y from the second equation with negative 1 half x plus 3. So we're going to start working with equation 2, which is 2x plus 4y equal 5, and replace, substitute y with negative 1 half x plus 3. So we're having 2x plus 4 times negative 1 half x plus 3 equal 5. So we're having 2x plus, sorry, not plus. Let's distribute. 4 times negative 1 half will give you negative 2x. 4 times 3 will give you 12 equal 5. So we end up with 2x minus 2x, which is just 0, and we end up with 12 equal 5. 12, it's never equal 5, so we know this is false statement. Since this is false, there is no solution, which means no point of intersection. The two straight lines don't intersect. So the lines are parallel to each other. The only way when lines don't intersect means they are parallel to each other. And system. is inconsistent, which means no solution. Okay. Also, what is important? On Alex, you guys have to check the settings. Sometimes when we have no solution, we can say sometimes, and again, just keep a note here, no solution. We may use two notation. I believe Alex used the empty set notation. Your book, when there's no solution, using like empty brackets. Okay, so just be aware of that. Before we have test 2, I will check how you will have to enter the answer, but just be aware. I think Alex, if I remember this from last semester, Alex used this notation. Book is using this one, the second one. So no solution. The two straight lines are parallel to each other. So again, if you're trying to find x coordinate or y coordinate, and you end up with something what is false, that means that we don't have a solution. The lines are parallel to each other. Okay, next example. Next example, it's about dependent system of dependent equation using substitution. So don't forget that dependent equations, that's when you have infinitely many solutions. So this is the example when you're going to have infinitely many solutions. So infinitely many solutions, which means those two straight lines which you see from equation 1 and equation 2, they represent exactly the same straight line. So they are equivalent equations. However, we still have to show work. Not all the time we can see it, that they are equivalent equations. So look what happened here. So let me start with equation 1, which is 2x plus 1 over 3y equal negative 1 over 3. So look what happened. Couple ways you can see that they are equivalent. They are exactly the same equations. I'm going to do easy way. I know that you guys don't like fractions, so to not have a fraction, there is 3 in the denominator, so I'm going to multiply all by 3 to avoid having fraction. So we have 3 times left side, which is 2x plus 1 over 3y equal 3 times the right side of equation 1. Distribute that 3 to all of them. So we're having 6x plus 3 times 1/3, which is 1, plus y equal negative 1. Okay, so 6x plus y equal negative 1. Okay, still this equation doesn't look like equation 2. Okay, so I'm going to follow the substitution method and I'm going to solve it for y. So I'm going to solve the first equation for y. I will subtract 6x from both sides and we end up with y equal negative 1 minus 6x. So this is equation 1 when I solve the equation 1 for y. What we're going to do next, work with equation 2 and replace y with negative 1 minus 6x. Okay, so we're going to replace it. So we'll have 12x plus 2, replace y with negative 1 minus 6x equal negative 2. So this is 12x. Let's distribute 2, so we're having minus 2 minus 12x equal negative 2. Look what happened, 12x cancel, and we end up with -2 equal -2. This is always true. So when you end up, similar to the previous example, but now we end up with something what is always true, the variable cancel, what that means, this system has infinitely many solutions. And what we know that those two straight lines from equation 1 and equation 2, they're graphing exactly the same way. So that should be fine on your homework. When you end up with something, when variables cancel, you end up with something what is always true. You already know that this system has infinitely many solutions. So that means the system is dependent. Your textbook, writing the solution that way. So again, the textbook, putting, if you have system of dependent equation, they're saying this way. The solution set not solution set, the solution of this system is the set of all order pair, because again, infinitely many solution means infinitely many points, which is ordered pair, on the line, on which line? The one which you solve for y from the first equation. On the line y equal -6x minus y. I'll just rewrite that in the slope-intercept form. Okay, so this is how the textbook leaves the solution. Write the answer for you guys. So here, just going back to what we learned on the next slide from section 12.1, just to interpret the solutions of system of two straight lines. So again, let's review that, because that's important we understand. So two equation, which means two line, may intersect at one point. So that's when you have in that one point x comma y. I think we saw two equations like that. That means that we have one unique solution. The two straight lines will intersect at one point. Now, when the lines are parallel to each other, that means you end up with no solution. There's no point of intersection. No point of intersection means no solution, okay? And that only happens when lines are parallel to each other, okay? So how are you going to know that the lines are parallel to each other? When you will be solving, you end up with something like contradiction, which is false statement. You will end up, your variables will cancel when you're trying to solve it, and you will end up with, let's say, 0 equal -3 or 12 equal 6. Something what is false. So that means there's no solutions. Those two lines which you have in this example are parallel to each other. Or that's the problem which we just solved. The lines may be the same and intersect at all points on the line, which means we have infinitely many solutions. And how you're going to know that you have infinitely many solutions? You're going to do your algebra. You will try to solve it for one of the variable. You try to use the substitution, and you will end up with something what is always true. Your variables will cancel, and you will have, let's say, 0 equals 0, 12 equals 12. This is definitely a true statement. Since variable cancels, so there's no way that you can solve for that variable. So that means, okay, we know that the system is dependent, and we have infinitely many solutions. And also when we're talking about graphing, if you will try to graph them, you will end up with, again, those two straight lines will graph exactly the same. They just represent, the equations are equivalent, so they represent the same graph. Okay, and what I will do with you guys, I will solve one problem, which is application of system of linear equation. So to solve this problem, we're going to use what we learned. We have one number is 16 more than another. Their sum is 92. Use the system of equations to find the numbers. So like you guys see, in this problem, we have to find two numbers. So we need to use two variables. So x will be the first number, y is the second number. Since you have two variables, you need two equations to solve this problem, which means we need system of equations. So we're going to start create the first equation. They're saying one number is 16 more than another. So I would say that one number, again, it doesn't matter if you label that as x or y, but I would say x. The first one is means equal, 16 more than another. So 16 more means plus, then another number, again, my second number, I introduce letter y for that. So x is equal 16 plus y. So I create the first equation using the first sentence. The second sentence saying the sum is 92. So when we adding those two numbers together, we'll get 92. So two variables, that means we need two equations, which is system. Okay, now we're going to solve it. We need to figure out what two numbers are. So substitution, we're going to replace x from the second equation with 16 plus y. So again, equation 1, equation 2. So replace x from equation 2 with 16 plus y. So we're having 16 plus y equal 92. And we're going to solve this equation for y. So we have 16 plus 2y equal 92. Let's subtract 16 from both sides. We end up with 2y, it's equal 76. Divide each by 2. And we end up with y equal 38. So we know that the second number is 38. So now we have to find x, which is, let me put it, second number. Again, it doesn't really matter which one is first, which one is second. Now, x, to find x, go back to equation 1. So equation 1 is x equals 16 plus y. So x will be 16 plus, we know y, it's 38. So we're having x equal 54. So in this case, x and y, again, they don't represent like coordinates. We're not graphing, we're talking about how we can use the application of system to solve the word problems. So again, we find it. So the answer is use the system to find the numbers. The numbers are 38 and 54. And 54. Okay. So that's it. This is the end of section 12.2. Hope you guys feel comfortable with this lecture. Make sure that you will practice those problems on homework. And tomorrow, I will upload for you guys a lecture from section 12.3, which is also about system of equations, but I will introduce elimination method. Sometimes they call it addition method.